Welcome everyone to another CTC software webinar. My name is Sean Zerbis. I'm the Director of BIM Development here at CTC Software. And in today's session, we're going to be continuing through this analytics learning series that we've been doing. And this is sort of a part 2 of a mini series within the main series that's going to talk about using Python to harvest data from the Web API. And in today's session, we're focusing specifically on getting JSON records, just pulling them down. This is a starting point. This is going to lay a foundation for our next 2 parts in this series. But we're going to be talking a lot about Python language today, and we're going to go through this in quite a bit of detail. Now, with that, as per usual, this webinar, of course, is being recorded. And this way, you can come back to this in the future if you aren't able to directly follow along with me today. You can use this as a recording, a refresher to step through this. Also, as always, of course, for those of you who are participating with us live in the webinar, I keep my eyes on that questions window quite commonly here. So that way, if you have questions about something that we're talking about, then you can certainly reach out there via the questions window, and we can try to get that answered in line. And we also save a large QA session for the end that doesn't actually get its way into the recording that's up on the YouTube channel. All right, with that, let's jump right in though. So I've said this before in this series, I'll say it again. In our modern culture, really, data really is king. And if you have the ability to leverage that data to make very intelligent, very wise, data-driven decisions, this can really make you more productive. It can give you a lot of power internally. It can help you direct spending efforts. It can help you with the decision-making. It gives you a lot of information to work with. Now, in part 1 of this little mini series, this sort of series within a series, we focused on Excel and Microsoft Power BI. And what this let us do is have a simple and yet customizable analytics environment. And the problem with this was that it's just for a specific set period, because when we're using Power BI and Power Query, it's not very easy to have sort of historic information go back further than what I can get in a single pull. So in this portion of this little mini series, I'm shifting gears a bit. In this part 2, I'm going to take a significantly more customized approach. We're going to lay a foundation here to really integrate the CTC Analytics data into your internal workflows. But to do this, you're going to have to dig a little deeper in your skill set and master, or at least become semi-proficient in some kind of programming language. I am going to be using Python because it's very common in sort of the data science space and analytics and data presentation and data cleaning space. So I'll be using that in this discussion today. And I'm going to show you how you can use this analytics API using some code that I've already pre-written for you to begin to capture this data. Now we're going to start again by capturing JSON files. I'm not going to use any of the JSON files today, but I'm just capturing them to show you how this works, and so you can get started with setting this up. And you can also begin to dig through some of what I've written so you can better understand the whole API as a whole structure. That's kind of the core of this aspect here. So in today's session, I'm going to kind of go through 4 points throughout the discussion here. I'm going to be introducing the Python data extraction process. We're going to talk about some of the ability to efficiently store that data locally, how you can cache some of this information. We are going to talk about integrating this into internal workflows, and we're going to get some strategies in place for some more real-time data harvesting. Now, we're going to be building upon this in the next 2 sessions, where we're going to be actually storing this data instead in JSON format. Next session, we'll be storing it in SQL. And the following session will be actually telling it to automatically refresh so that all of this is hands-free and way less complex on a day-to-day basis. But let's get into this in the first part. First off, let's just recap real quick where we are in the series as a whole. There's all these sort of 8 major sections in this overall series. And so far, we've covered the first 5. And right now today, we're here in the 6th overall part, the sort of part 2 mini section, using Python to harvest JSON content here. Now, if you've missed any of those previous sessions, They're all recorded, they're all on our YouTube channel, and they're all available for you to go back and review. And there's some very important kind of prerequisites that are discussed here in the reporting API getting started. We re-talk about them here in the working with the Excel and Power BI files. And just because I know some of y'all maybe are coming into this a little late, I'm going to recap some of those prerequisites again, but I'm not going to go into near as much detail as I did in that getting started session, where we really dug in and talked about some of the inner details here. But we'll rehash it real quick here. So prerequisites. Part 1, you need to get an API key, a reporting API key from CTC. If you don't have the API key, you can't interact with the CTC API. It requires having that. It doesn't cost you anything. You just have to be a CTC customer, and we'll give you an API key just to make sure that you have a secure key to work with. The way that you get that is you reach out to licenserequest@ctcsoftware.com. Email them, say you want a reporting API key. They'll send you one back, typically in a few minutes. The other thing that you're going to want to do, so you can follow along very quickly, since there's a lot of code at play already, is you're going to want to get the base Python data set from GitHub. And you can get that by going to github.com/sean_reporting_API. You can go there. You can get that, the current repository. If you need to have sort of some tutorials on how to clone a repository, there's stuff all over YouTube. I'm not going to rehash that. That's already all over the place. I will make one recommendation, and that is to leverage GitHub Desktop. It's going to make your life a lot easier, especially in future sessions as we go through some of this content. The other thing that you're going to want, since all of this code is written in Python, is to install at least Python version 11 point whatever or newer. I'm currently using Python 12 today, actually, but it doesn't matter. All of my code works in Python version 11. That's where it was begun. And I haven't been using any of the newer functions inside of there. So Python version 11 or newer, just install that. You can go to python.org. You can install it. It's free. It doesn't cost you anything. Just make sure you have that installed. The other thing that you're going to want, I'm going to recommend using Visual Studio Code, Microsoft's Visual Studio Code. It's an IDE, or an integrated development environment, an IDE, and get that installed. It's also free. Visual Studio Code is free, and then you can install on top of that the Python extensions, which makes Visual Studio Code work really, really well with the Python language. And I'm going to show you a little bit today about establishing the working environment within there. So you can kind of have a quick start tutorial on that. Now, before I get into the working environment too much, I am going to talk about refreshing the current repository. There was a recent push as of this morning. So inside of GitHub Desktop, if you have that repository already cloned locally, you'll probably see the ability to fetch the origin here. And I'm going to go ahead and fetch it again right now. This is going to download to me the very latest from that main branch that has sort of the released set of code here. So just fetch that. You'll be able to do the exact same thing if you have GitHub Desktop set up and you've got this repository cloned locally. In my case, mine is cloned to my C drive. You can put it wherever you want. It doesn't matter. The location of it is irrelevant. All of the stuff inside of it is relatively it's relative pathed, so you don't have to worry about it being in a specific path. So as long as you fetch it, you're good to go. So I have that latest environment. Now, within Visual Studio Code itself, and by the way, I've opened up that particular folder, my CTC Reporting API folder in Visual Studio Code. This is currently what it looks like. I happen to have the README pulled forward. And there's one part in the README that I want to just rehash one more time in this webinar series, and it's down here in the using the Python code. There's a couple of bullet points here. CTC Software as a company does support their API. They absolutely support their API. However, this code in this repository, this is my personal code that I'm freely sharing with the world. CTC does not own it, and therefore CTC does not support the code in this repository. If you're having issues with the code in this repository, you absolutely must reach out to me directly, because none of our reseller partners, most of our support team, they're not going to understand how to support this. So really important that if you need help with this, that you reach out either via GitHub or you can email me at CTC, but this is not CTC code. Just want to make sure that's very clear. Doing this on behalf of CTC so that, you know, I can show an example of how this is all useful, and I'm giving out a data set basically, but it's not a supported data set at this point. Just the actual API itself is supported. Okay, so the first thing you want to do within Visual Studio Code is you want to establish a virtual working environment. Now, if you have been learning Python recently, if you've been watching tutorials, you may have heard some of the instructors talk about virtual environments, but usually in the early essentials, they don't talk about this. And I kind of fell into the trap of not working within a virtual environment, and it kind of you know, shot myself in the foot a couple of times, so to speak, with my coding and with a couple of different projects that I was working on at the same time. So it's always best when you're working with a code set, especially if it's from somebody else, to get a little virtual environment to work in. And it's actually pretty simple. In Visual Studio Code, you can do this directly. Python, the programming language, helps you do this directly. It's not like you need a virtual machine. You don't need a virtual Windows instance. You can just tell Python to make you a virtual environment. And in fact, in this code, I'm going to do this right now. I'm going to close the little README. I'm going to be here in the little terminal down here at the bottom. I'm in this little repository, and I'm going to build myself a virtual environment. You'll notice that over here, there is no virtual environment folder just yet. I'm going to make it directly. So Python, if I can spell, -m, you tell it to make a virtual environment, and then you tell it what name you want that virtual environment to have. For me, and a lot of people will also just call it VENV or virtual environment, sort of a shortcut for that. You can call it whatever you want. This little second field right here, you can do whatever you want for this. In my case, VENV is what I'm going to call it. And what it will do is it will put that virtual environment into that little collection. You're adding to the code set here. That's what you're doing. Now, with that, you are also going to activate that virtual environment, and you'll see something a little bit different on the little terminal down here. And by the way, if you don't see the terminal when you first open up the Visual Studio environment, you go to Terminal, New Terminal, and that will build you a little terminal window down here that you can type into. It's kind of like a Windows command line, and you can actually do a lot of this stuff from the Windows command line too, if you feel really comfortable there. I like using this development environment because it makes it a little easier for me, but there's always going to be a little bit of typing when it comes to code. So to activate the environment, it's a very specific command over here. It's actually VENV, you're calling that folder, /scripts with a capital S. Python's very case sensitive, so we're going to be seeing that. I'll be very particular inside of here as I'm typing things out. You'll see caps versus lowercase letters. So /scripts, /activate. So inside of here, I am going to type that in. So virtual environment, venv here, /scripts. If I can type, /activate. There we go. I'm going to hit enter, and what we'll see is that it'll put a little VENV, a little green prefix over here. Whatever the name of your virtual environment is by the name of this folder, it's going to prefix this with it. That lets you know that you're currently working in a virtual environment. And then whatever you do from this point forward, here, whether you install some stuff into Python, you know, whatever you do, it happens within this virtual environment, and it kind of protects anything else you might be writing from, say, mismatched versions of stuff. Okay. Now, another really important thing that you have to do is you have to create for yourself an env file. I'm doing this on purpose. Actually, I think it's lowercase env. I can't remember now. What is it? Yeah, my bad. It's lowercase env. That's on me. I didn't put that in there correctly. Let me just change this real quick here. Env lowercase. I don't know why I capitalized it. Doesn't really matter. Back here, back this up. Hey, look at that. It's being all kinds of screwy. There we go. Create a .env file. This .env file contains just a setting, and I'm going to show you exactly what it is. I'm going to show you exactly how easy this is to create it. I've given you a .env sample. I'm not giving you my real env file. That's in my little, there's a little get ignore file here. It says don't publish certain secret things, certain things that shouldn't get published to the internet as a whole. And one of those things that you typically don't publish are things that contain secret keys or API keys or access keys or things like that, passwords, stuff like that. So this is just a safe way of working with this. This .env file here, if you copy this, copy and paste, you can rename this file, simply rename it and change the name to just .env, okay? You'll have the exact structure, the exact codes that have to be inside of here. Now, the only one that matters for today is this report API key. When you email license request at ctcsoftware.com and you get that report key, you're going to want to paste that key, whatever that is, right here. Now, I'm obviously showing it in the webinar. I don't really care. I can change the key in the future, but it's not something you would typically publish. So this will not be directly in line in my code anywhere. It's going to call the variable here CTC report API key, and this is what's going to be actually in my code. So this is sort of kept secret, so to speak. So you're going to edit this. You're going to save this. The next thing that you're going to do after you've pasted your reporting API key into that .env file in the report API key row between the quotation marks, then what you're going to do is you're going to install the requirements that are necessary. And this installs those requirements into your virtual environment. So this one that we created up here, we created a virtual environment, we activated it. We're now going to install some required extra packages into here. Those of you familiar with Dynamo packages, this is a lot like getting a Dynamo package. We're just going to install those into this environment. And you do that with a little command line call here, pip, which is Python integrated whatever something, install -r, which tells it to read a requirements file. And I'm going to tell it the requirements file is requirements.txt. I'll show you where this is. Inside of here, there's a requirements.txt file. It has a few items that I'm using or will be using in future steps here in this series. These little requirements right here save you from having to type out each one individually. A lot of times you'll see people in the YouTube videos saying, yeah, pip install X package, whatever that happens to be. Doesn't matter, whatever it is, you pip install it, except for I didn't type pip correctly. It doesn't matter. Here in this case, you're going to pip install the requirements that I've already laid out, which is these ones here in this requirements.txt file. So pip install -r the requirements.txt, okay? And when you hit OK here, enter here, it installs those into, except for I didn't type install correctly because I can't type great. There we go, pip install, there we go. It's gonna take it a second, it's gonna rip through and get all those installed into the virtual environment. So here in the virtual environment, there's a libraries collection here with a bunch of stuff, all the things that are required and dependencies there, they're all installed into this little packages area here, and you don't have to even think about it anymore. When you come in tomorrow and you start using this, the only thing you have to make sure that you do is make sure that the virtual environment is active so that it can actually harvest from those specific packages and depend on them, build upon them, and we'll see kind of where one of those gets referenced here in a moment, most likely. All right, so with that, let's go through and do a quick code tour of what's in here. So I was talking about packages. There's a few that I am depending upon that are very important for this little workflow here. The first one is the requests package that got installed with that requirements little text file. Requests, what this lets you do is reach out to the internet from your computer via this requests package and ask for stuff from the internet. It lets you request things from some HTTP address and receive that result back into your local code. And in our case, it's going to give us the JSON data that we need from the CTC requests API. Or rather the reporting API. The other thing that I'm using is this python.env package, which is called by the .env name inside of Python itself. That package is letting me rely on this .env file right here. This is the file that lets me keep that reporting API key secret so that it doesn't grow legs and go anywhere, other than, of course, the fact that I'm flashing it on screen in today's webinar. The other package that I'm relying very heavily on is a package that's called Pydantic. Pydantic is a really, really cool package. What it lets you do is take data that comes down in some raw format and very strongly format it. It's called strongly typing. You type it into a really specific format, and then you can trust that format because it's already been pre-validated, and in the future, you don't have to keep trying to revalidate, does this have what I expect? Because you'll know that it has what you expect. And I'm going to show you a little bit about what I've done to build some Pydantic data models inside of here so that you can kind of see all of the back-end work that you can just piggyback on. We'll go through that in a minute here. In fact, we'll start by touring some of how that's working in the API core area here. So in the API core folder, that sub package, I'm kind of each of these folders inside of the reporting API overall program here, each of these is effectively considered a package according to Python. Now, the API Essentials folder we actually already looked at in previous sessions. This is where the Excel files and the PowerBI files and some of that Postman setup stuff is, so you can navigate through and understand the API as a whole. We won't be talking at all about this today. Instead, we're looking at this API core little area right here. In the API core area, there is a settings.json file. That file right here helps you specifically change how many days back it is you want to go for some data. Now, I have the default set to 30, but you can technically set this to as far back as you want. You can go a year back if you want to. I wouldn't do that, but you can. It's going to take a really long time if you tell it to go get a year's worth of data. So start with just a little bit of information. You can start with a day. You can start with 15 days. You can change this to whatever you want. Within the Excel environment, it was very strongly configured. You could go 1 day or 7 days, 15, 30, 60, 90, and 180, and then that stopped. And we're going to actually see in future sessions how you'll be able to leverage this and actually even bypass this with your own logic if you want to within the Python space, because you can actually tell it to go 1 day at a time, every day, sync up. But for right now, we're going to tell it to go get 30 days of information. So inside of here, there's also some other things like how many rows of data do you want to fetch per page. This can help you sometimes if your computer that you're running it on maybe doesn't have near as much memory. You might want to lower how many pages it's pulling at a time, and that might just help it run a little bit faster or more efficiently locally. I shouldn't say faster, because the fewer pages you grab at a time or fewer items you get per page, it actually takes longer to fetch the data, but it's lighter weight on your local computer. So you can adjust this. The maximum, though, is 1,000. And then there's some other things like some logging names and some other stuff that I'm just using. You don't have to worry about these. They don't really mean much other than this little prod area here. It's telling it where to look for data. Since I'm targeting other areas in our back end as well, I just have this here. But by default, it's using the production environment here, pulling data from prod. All right. So the other aspect here is this connection models folder. So we're going to start seeing some of this in Pydantic now as I kind of navigate into this connection model area right here. What this lets me do, specifically with the collections in particular, is it helps me figure out exactly the structure of the request going up. So there's a series of optional switches that you can use when you're fetching different kinds of information. Let me go to the CMS content area here, because this one has quite a few switches. If I'm looking for a specific content record, a specific entry within the Hive CMS environment, I can choose whether or not it decides to include files, or whether it includes, if it's a Revit family, the type definitions within that family, whether it chooses to include the parameters that exist within one of those types, right? And you'll notice I have this set to false here. This is false because if you decide to go after the parameters, that request takes a really long time. A lot of your families have a lot of parameters. There's a lot of power you can do with this, but I'm not going after the parameters in today's poll just because it would take too long to demonstrate what actually goes on there. I am including the types, and it doesn't take that long, but you can include other things, attachments, downloads, loads. This is all stuff that is available if you go take a look once again up here at the Postman environment. In the cms.json Postman file here, when you're looking at Postman collection, you'll see all of these available switches. And I basically have built them in here so that this can decide whether or not it should or should not actually go fetch that much information. And it makes it real easy. You just simply switch this from true to false, and it'll decide for content whether or not it fetches that stuff. That's as simple as it is. But this particular collection here has a very specific structure. It has a name. It may or may not have a parent. It has some mandatory switches here potentially, whether, in this case, like for when you're fetching content, it requires the content ID. And then it has optional switches. Nearly everything has optional switches, but not everything has a parent and not everything has mandatory switches. So there's some controls in here to kind of determine how that is supposed to actually work. All right, so there's also things like scopes. The scopes here, the accounts scope understands which collections are related to it. They're children of it. The CSL, the Cloud Shared Licensing scope, understands which collections are children of it. And I'm just using this so that my logic knows how to go kind of through and figure out what's related to what and where it should be pulling a particular request from. Okay, so that's the connection models area here. You can tweak those a bit if you want to. Again, changing the true false is probably the most common area, but there's a lot of stuff inside of there that you don't have to even really worry about because it's just pretty static componentry there. The other portion here is the get functions, the core get functions. This is going to be very similar to what we looked at during the Excel Power Query area. It's very similar to that. The logic is actually 100% modeled in the exact same way as what was done in Power Query. But this is sort of where the heavy lift actually happens. I'm going to go take a look at this real quick. What this will do inside of here is it loads up the .env file so that it knows here what your API keys are. In fact, it pulls the API key in from there. It gets some other settings to understand, where, how many days to be pulling, how many rows per page. You can see it's kind of filling that out. How many days offset it's supposed to be using, if there's a log title to leverage that. So just pulling some data, some settings from those files. And I put them out here so you don't necessarily have to get into the actual code to modify those settings. You can just go here real quick and make some modifications there. Now, within here, we're going to go down to, we'll go take a look at getting a specific collection of objects. So this call right here, the get next items right there. Inside of here, it wants to know what scope it's looking for. If it's going to CSL, the Cloud Shared Licensing, if it's going to CMS or accounts or whatever. So it uses one of those little scope objects to pass through that. It also wants to know specifically which collection to go after. This is whether it's contents or libraries or you name it, users or groups. So that way it knows what it's supposed to be doing there. It has sort of what page number it's on. So it knows which page specifically to fetch. And then down here, it starts to assemble all of the different properties. So it adds the switches from the collection. It generates a URL from all of that information. So it knows what scope, what collection, what page number to fetch, what the switches are, true or false. Do I get this? Do I not? There's actually a function called generate URL or gen URL here that's up here at the top. You can go through this if you want to, but all this is doing is assembling a string of a .html URL. Feel free to navigate through that if you really want to. If you want to optimize it, fantastic, go for it. But it's just basically getting a URL. This is the exact same thing that was happening in the get URL function in Power Query. Then what it does is it tries to reach out to get a response using that requests package. And it gets information from the URL. If it takes longer than 2 minutes, in this case, 120 seconds, then it will time out and it will just not fetch data. But if it takes less than that, and our API typically always responds in less time than 2 minutes for each request, it will get a response back and it returns to this response the text. So it just turns this into just basic text, and then it loads that response into a variable here. And then it returns that back. So all this is doing is getting some JSON data and passing it along. That's literally all it's doing. The other little action inside of here down below is a get all X. So it goes, say, with the contents, right? The contents, if you remember, you can get 1,000 items per page. That's it. If I was on page 1, I get 1,000 items. If I'm on page 2, I get the next 1,000 items. If I want to get, in my case, 7,600 entries of content, I have to cycle through 8 times to get all 8 total pages to get all of the stuff. And so what I'm going to tell this get all is how many rows total there would be, 7,600, what page number to start on, if anything, what scope and collection I'm going after, and then this thing will recursively go through and figure out what page number I'm on, add 1 to it if I've already got a page, and then just keep cycling through and get the next X items each time through. Just keeps getting next X, next X, next X, builds me up a total list of all of the items, and then it returns that list of all of the items back to whatever. So this is just core, raw, unvalidated JSON information. That's what this get API functions will do. There's one other call inside of here that will let you get items, the details of a particular item. Let me find out where this is. Here we go. Get X by ID. So get, say, content by content ID. Get a project entry by a project ID to get the details about it. This does require an ID. That ID is basically going to return back, again, similar deal. It reaches out with all of the switches, it generates a URL, it gets the response, and it gives you back just raw JSON as a dictionary down here, and it just returns the data back to whatever's calling it. So very core, very raw function here. The same exact thing that was happening inside of the Power Query is doing the exact same thing here, but it's converted the language from Power Query here into JSON code. So this is about as raw as it gets. You could directly call any of these for your own purposes, however you want. You can feel free to call this. Okay, so again, you can fetch this entire repository of all of this code, all of it, via my link from GitHub earlier in the presentation today. Go to GitHub, clone my repository. You can get everything, all of this code, just in case that question comes up, because I do know that question comes up periodically of how do I get this? And again, GitHub, that's what that's for. It helps me distribute that and keep it up to date as I make changes. Okay, next little step here is as you get these results back, I have built out very specific models for these results. A piece of content from the CMS has a very different result than a user result from the accounts system. So I've pre-built out a data model so you can actually ask it for information, and I've standardized across all of these results naming conventions for you to save you the headache of having to do some of that yourself. When you get just the raw JSON, which you can get, there is always going to be a little bit of sort of cleaning. In the world of data science, there's a 3-step process called extract, translate, and load, or ETL. That ETL workflow, that translate step, is usually where most of the time is actually invested. You might go out and scrape a website, pull down some data, but you got to clean it. You got to make it usable somehow. And that's what these result models are for. As a part of the API core, what I'm going to be able to return to you via this code is a specific model that is very standardized. It knows how to translate everything. So let's take a quick look at some of that. Inside here, if I go into the result models, there's a result model for each of the scopes that are available. So there's an account scope, a CMS scope, core you can ignore for now. This is just for something I'll be using with the SQL workflow later. There's a cloud shared licensing scope, and there is a PAL, or a project activity log scope. Those scopes, if I go into something like the accounts scope, and I go into my organization users little collection here, this again is leveraging the Pydantic environment to create for you a very strongly named account user base model. And this will have things like the user's ID, their first name, last name, and display name if it's in the system. You'll notice in some cases here it's calling out optional in some cases, and it's calling out mandatory fields or non-optional fields in other cases. This is meaningful because now you can know 100% from this data model that there will always be an ID associated to a user, but there may not always be a first name or a last name if you didn't put it into the web portal. Because those are optional fields in the web portal, that means that I don't necessarily know there's going to be a value coming back. So you will always have a first name field, but it might be nothing, because that will be the default if for some reason a string of a first name doesn't get sent back to you. There will also always be an email. There may or may not be a description or an office or department, but you can get that information and know that it's going to come back in a consistent way now, because this data model knows how to translate that. There's also some times when within the back end of our system, there might be, say, a time sort of field where something was created at a time or added at a time. In the back end database, it might have been stored that way. And so what I have done is, in all of the records where a date timestamp is meaningful, there will always be an added at field that's available there, and it will translate whatever might be coming through from the backend API. So you don't have to worry about what that is. It's going to come back very cleanly. Similarly here, there's sometimes different nomenclature in the system that returns data back to you that might say added by ID or added by user ID or created by user ID. Again, I'm basically giving aliases to whatever those fields might be and whatever they might change to in the future, so that you can always trust that the data coming back is going to be called added by ID. You'll see some things in some of the updated bys in the future as well, sort of similar sort of data validation. And then within specifically users, I have a get all users option. So you can very quickly just say, give me all the users, and you don't have to go through any of the other code. It will give you back a users data model that tells you total number of users and gives you a list of specific data models of individual users, user by user by user, and that will all be, again, very strongly typed data that allows you the ability to trust what that structure is going to look like 100%. Every one of these different models here is the same thing. Groups has sort of the same deal. There's a base account group that has structures of how it's going to be used. There is a groups plural model here that tells you the total number of groups and each individual item within that as a list. And then there's a get all groups call that basically tries to reach out to the base get functions, and it says, get me the total items, get me all of whatever the groups are, and then validate that result into the account groups data model. And if something comes back squirrely, it's going to yell at you. It's going to tell you, look, this data has been inconsistent, or it's outside of the data model for some reason, and it will let you know that the data might not be trustworthy. In my case, I'm got it down now, I think, to a science, and it's all very trustworthy for you, so it makes it real easy. Each of the calls, roles, users invited, if you want to get the invited users, all of the CMS data here. For contents, for example, contents is a really big one. It's one of the biggest data models that's out there. So this knows how to go through and have the base content record. It knows how to build a full content record with all of its downloads and files and attachments. The files understand what their properties are. Everything inside of here is all very strongly typed. And all you have to do is reach out and get all content if you want. Or you can reach out and get all content details if you want. All content details, 100%. Or you can reach out and get a particular content detail by the content ID, and it will give you, again, a very strongly typed data set back that's going to be consistent. It's going to be normalized. The names will be standardized, and it gives you a lot of relief and a lot of headache in the whole authoring up of this in the first place for yourself. So all of these models are already pre-baked in. That's what the result models are for. There's one final piece of code here in this API core, and that is the main PI file. This main file within this particular package down here basically takes all of that previous information and it sums it up, wrong one, this one here in the API core main.py. It sums it all up into a collection of simple calls. It loads all of the different modules that you need inside of here. It loads in a get functions list. You can get the core elements from everything, or turn them off if you want to. If you're like, hey, Sean, I don't care about the CMS stuff, great. You can simply comment this out, and you will never ask for CMS data because I've commented. Well, actually, I should probably comment out CMS content as well. Comment that out. Then it will never ask for any of the CMS data at all. And it's only going after accounts data, maybe cloud shared licensing data, maybe project activity log data. You can choose what it is you want to go after and what you don't, very simply by just not including in the get functions list a function you don't want to go get. It also knows how to get data by ID. So it does the individual by ID calls and gives you individual JSON files one by one, or you could choose to, if you wanted to, leverage the all. I'm not using this one because I won't be using this in the future, but I gave it to you for a simplicity's sake in case you wanted to just go fetch all of the details in one big file. You could do that, but I won't be using this in any of the other parts of my code. It's just there for convenience factors. So then down below, I have a get base records, a get details, and a get by ID call that makes it real easy to basically use one of these functions to just get it. I can pass in whichever of these functions I want, and it goes and grabs those records and returns them back as objects. So then I'm using this in the next step. Today, we're talking about JSON. So let's tour the JSON package inside of here. Inside of there is a settings.json file, just like there was in the API core. This settings.json file here in the JSON package here allows me to basically decide where I want these files stored. In my case, it's going to ctemp CTC API. You can put this wherever you want it. Want to put it on a D drive, want to put it on a network path, you can put this wherever you would like this file set to go, and it will automatically build a subdirectory in a little dated subfolder here by default for this. The next major part of this is the create JSON cache files. This is actually going out and using the API core code to go grab a bunch of information here. So inside of here, that's this little module right here, create JSON cache files.py. This is telling it to leverage that API core main that I was looking at just a moment ago, and it's pulling in specifically and using the get by ID and get functions that are defined inside of there. It already has that defined. The JSON settings here knows where the JSON settings file is. This knows where that path is basically. It's going to be able to drive a current date time right at the start. This helps me drive that folder name. And it also understands, because I'm using some asynchronous multi-threading inside of here, I'm telling it how many processes are allowed at the same time. I'm taking your CPU count on your computer, I'm dividing that by 2.5, so I'm getting about just under 50% of the processing power for the two different major functions. This should use up to, but typically not more than, 60 to 70% total of your processor powers on your computer. So I'm not telling it use 6 cores. I'm telling it to figure out what you've got available and use, about half of that, give or take. There's actually 2 different functions that run simultaneously, so it uses half of that for one of the functions and half of that for the other functions, but they kind of balance each other out. So then within here, this will create the directories that I need. So it'll create that root directory. It'll create the container, which is a date timestamp folder or whatever you tell it to be. The default is date timestamp. It will understand here exactly how to write a JSON file. So it takes in a JSON stream, that JSON data. It converts that in, it builds a file name. It understands what sort of sub-container it should go into, and a subdirectory. So then it writes that file out there into whatever that directory happens to be. Is just simply a write of a .json file. Here I have a get base JSON. This tells it to go get the base collections. So whatever those are, that would be contents or libraries, just the base records. And this is saying within here, the records is going to equal some kind of a function. We'll pass in a function in a moment here. This is the one that tells it which get call to go call. It takes the JSON data here from that, whatever that record is. It dumps that information to JSON, loads it into a parameter, and then it calls that write file command here to write that out to some JSON file. In the future, this will be actually storing data into a SQL server. So there we go. All right. The get all JSONs here basically calls this for every single collection that's available. So it's looking at that get functions collection, whatever items are available there. And it basically says within there, asynchronously, use as many cores as you're told you're allowed to use, go in there and just get all of those base components. And then if those base components has a detail in that get by ID function here, go in asynchronously, grab all of those. And then when you're all done, close out that little call in memory, and it's basically done. There's also a little call here to get detailed JSONs if I need it. I'm not actually using this, but that is a call that could be used if you wanted to get individual JSONs specifically by a specific item. If you wanted to call that individually one by one for your own purposes, that call does exist and it'll write that JSON file to a specific location. This is not an asynchronous call. This is just a one-off, get me that one with whatever the function is. So if you're like, hey, I know that this particular piece of content got updated, go get its ID, its data, go pull just it down. It could pull one really detailed content record or one really detailed project record if that's what you wanted to go after and save just it to a JSON file. So it's an option to be able to use that. All right. So now let's talk about the final interesting thing here, running the actual code. Now we've talked about the prerequisites that have to be set up in place. We've talked about what the little functions are all doing. I'm now going to boil this down into a very simple workflow, what I call simple, because I'm used to it, of course. But as you go into this more and more and you try to use this more frequently, I think it'll become simple for you as well. What we're going to do is open up the main Python file from the CTC reporting API main directory. So we're going to do that here. I collapse everything else out. In this main directory, there is a main.py file. And all this is doing is saying, get me all the JSONs. It's calling that one function. There's also a little timer that's baked into here, so it can tell you exactly how long it took to go get all of those JSON files. So it'll have a start time, it'll have a finish time, and then it'll tell you at the very end when it's all done, how many minutes did it take to go fetch all of this data, however long that was. So that's one. Open up the main.py file. Number two is before you run this, so that you can know that it's going to work well, you should verify that the virtual environment is active. Remember earlier we talked about activating the virtual environment, and you know it's active because it says down here VENV, virtual environment. It tells you that you're using this virtual space here right now. That's important because there's dependencies that are installed specifically into that virtual environment that you need for this code to work. If they're not there, this won't work. It'll yell at you. You should also, at this point, make absolutely certain you have a .env file. Earlier today, when I was practicing, I forgot to build myself a .env file, and I hit run, and it came back and said 400 error. What that means, that 400 error, is you don't have rights to this space because I didn't tell it what my API key was. It said you can't get here. So you need to make sure you have that API key. It needs to be in this file and saved, and then you're going to be good to go. Okay. Within here, then all you have to do is run the code. And we're going to start the code running right now, and then we're going to talk about some indications that it's running successfully. So to run this code, what I'm going to do is use run and just start debugging. The keyboard shortcut for this is F5. If you're just in a window and you hit F5 on your keyboard, it will begin running the code. Now, if this is your very first time doing this inside of the Visual Studio space, it's probably going to ask you for what interpreter do you want to use, and you got to make sure you pick Python as the code interpreter within here. But I'm going to go ahead and hit F5, and this is going to begin to run. Okay, it's running. So while this is running, let's take a look at some of the indications that this is running successfully. Indication number one is you don't get any massive errors right up front. There's no errors showing up here. There's some code that's showing up here, but there's no errors showing up. The second thing that it's running successfully is you get this little play bar and pause bar over here. Number two is that you've got this call stack. If you go to this run and debug area, you'll have this call stack, and it will be filling up and unfilling itself as the different processing threads are doing their work and finishing up. You can see it's kind of changing over here. The third way that you'll know that it's working is there will be in that folder, whatever you told it to go to, in my case, ctemp CTC API, there is going to be a folder inside of here from the date and timestamp when you started this. Today it's 4/17. On my computer, it was 12/49 when I started it. So this here is filling in with some base data right here, and it went and fetched me all of that JSON information. You can see it filling out files here, specifically in this folder. It's filling it out. And you can see in the details here as it's going through and actually populating this with items. You can see here in the contents, it's populating, it's going and fetching a whole bunch of stuff for me right now, populating in this folder. I currently have this sorted. I'm going to set it up so it sorts by date and timestamp here. You can see it just flooding this folder with a bunch of files that it's been told to go fetch. In my case, because I've got 7,600 pieces of content in my Hive CMS environment, this folder will ultimately have 7,600 distinct files. Example, if I go to this previous fetch from earlier today and I go to my details, in this contents folder, you'll see 7,600 items. Specifically, that's the number. I know it's the number because in my base contents pull over here, CMS contents.json, this is the raw data. This little 10 meg file here has base records for every single, oh, hang on, pull this across, here we go. Every single piece of content, every one of those 7,600, it has the base data. Its ID, who updated it, when it was updated, updated by, the file name here, the source, if it's in the cloud or not, all that data, whether it has a preview image or not, all this information is at my fingertips. Now, it doesn't have the details, doesn't have the files and the attachments yet, because that information is specifically inside of the details records over here. If I go into details content, if I reverse this to give me the very first piece that I went and got, this would be probably, well, I guess it grabbed at random one of those things. But here's the RFA. That's a specific AZ, must be, I don't know where that is. English Universal something, whatever. But it got a piece of content inside of here with all of its individual components. These are the type definitions. It did not go and get the parameter values because I told it false on that area. But it does go in here and say, oh yeah, there's these other components here for this file that are associated. There's potentially, so each of these individual files by version year, this is the 2021 file record, it's got its own components inside of here. Eventually I'll get down to the revisions. This is individual uploads of this file by somebody on my team at a particular date and timestamp. Doesn't look like this has ever been tagged. It has no libraries that it's associated to, or I wasn't fetching that probably. That's probably set to false, and it's not favorited by anybody. But I can see these different records inside of here, and it's never been loaded. It's never been used, never been downloaded. Apparently I spelled that name wrong. I should probably go fix that in my data record. But yeah, this is going after and fetching all of this information. All right. So that is currently actively right now populating all of this, and it's getting up there now at 1,600, right? Almost 1,700. It's going to go fetch, and it'll probably take a total of about 6 minutes to go get everything that's available for me, all of my base records, all of my base details with the options I have set. Probably take about 6 minutes to fetch everything start to finish. So I'm not going to continue to watch this. We might come back to this during the QA session at the end and take a look at the final result of what this looks like, because it's not fun watching just files populate down, at least not for most people. I've always found it kind of interesting, but that's me because I'm weird. All right, so those are some of the indications that it's running successfully. You'll see those things actively happening. So where are we? Well, we've talked about a lot of specific things so far. All of the previous stuff in this series we've covered up to today, which is using Python specifically to harvest JSON content. I intentionally did not dig deep into the Python language itself. I'll let you guys figure that out on your own. There's plenty of videos and trainings on that on the industry. What I wanted to do is just show how you can leverage that Python data to very specifically pull down really rich data locally. In our next session, the next part, we're going to be using Python more, building upon everything we've already talked about, but instead of storing it in individual JSON files, which personally I don't find super useful, What we're going to do instead is take this data and store it in a SQL database. And then it becomes really useful at that point. So next session, we'll be talking about storing it in SQL. And then the session after, we're going to talk about how you can much more automatically, more hands-free, continually update and refresh that data in SQL. So every time you go to it locally, it has the latest and greatest data, provided you're fetching the information. So with that, for right now in this session, I'm going to go ahead and say thank you. Now, of course, we're going to have a QA session here in just a moment, but for those of you watching this on the YouTube area in the future, I want to say thank you. Hopefully you made it to the end, and that's great. If you like this, well, of course, do the whole like and subscribe thing so you can get more of this kind of content.